Hi, we are going to talk about graphing linear inequalities. And just remember that linear has this word in it, line, which means that it will form a line. And before we've done linear equations, which, it draws a line, but these are slightly different because the answers aren't just the points on the line, but they're kind of around it. So before we start, we're going to do some vocabulary right here and symbols. So hopefully you remember this symbol means greater than. And this one means greater than or equal to. Okay? This one, less than. Less than or equal to. And this one is just less than. You can tell the difference because they kind of have like a little piece of an equal sign underneath the inequality sign. All right. Now, greater than, when you graph greater than or you graph less than, your line will look like this. Hold on, let me use the same colors I was using. It will be a dotted line because it's kind of like little holes that fall through. For less than, you will also graph the line dotted for the same reason. But if it says greater than or equal to, it will be a solid line, and less than or equal to will also be a solid line. Okay, and last part. If it is a greater than equation, you have something greater than something else, for these, you're actually going to shade the graph. You're going to shade above for greater than. For less than or equal to, you're going to shade the graph below. All right, so that chart should be pretty helpful to refer to later, so you may want to pause the video and write it down. We're going to do some examples in a few minutes, but for now, there's one other thing you might see. It might ask, is a point a solution to an inequality? If you want to know if it's a solution, you're going to substitute the point into the inequality for x and y. And then you will simplify the inequality and see, does that make sense? Is that true or is it false? So here's an inequality right here, a linear inequality. 2x minus 3y is less than 15. And the question is 2, 5 a solution to the inequality above? Well, we know that 2 is the x and 5 is the y. So we're going to substitute that into the equation. Remember, when we substitute, we stick the thing into parentheses. All right, so 2 times x, now x is 2, minus 3 times y, now y is 5, is less than 15. And now we simplify. So this is the only side we can simplify, so we're going to do that. 2 times 2 is 4. 3 times 5 is 15, is less than 15. 4 minus 15 is negative 11, and negative 11 is less than 15. Is that true or is it false? Is negative 11 less than positive 15?
True.
True. That's Chase. He's my boy. So, yes, this is true. So, yes, I'm going to write yes on here. Yes, 2/5 or 2/5 is a solution to that inequality. All right, let's do that one more time. Is 0, 0 a solution to this inequality? So 2 times x minus 3 times y is less than 15. We have our x and we have our y. So 2 times x minus 3 times y, substituting in, is less than 15. 2 times 0 is 0. 3 times 0 is 0. 0 minus 0 is 0. Is 0 less than 15? Yes. So yes, this is also a solution to the inequality. And I'm going to show you something pretty cool on Desmos so that you can see how that would look on a graph, because sometimes it's easier to see that way. All right, so I'm just going to type in the inequality, 2x minus 3y is less than 15. See how it shades the graph? It's kind of cool. This is what I mean. Oh, did I put greater than? No, that's less than. Oh, okay. Even though it says less than, this will probably confuse you right now because I wasn't really thinking. Even though it says less than, when you solve this equation to put it into y equals form, it will switch to greater than, which we'll do some examples of that. But that's why it's shaded above. And it was saying, is the point 2,5 a solution? 2, 5. Okay. Do you see how it just put that blue point in the shaded area? That means 2, 5 is a solution. All right. If we did 0, 0 as a coordinate, is that a solution? Well, is it in the shaded area? Yes. So yes, it is a solution. All right. One thing that you would have to be super careful of is, let's look at the point 2, 1. Do you see? I'm going to zoom in so you can really see. Do you see how that point is on the dotted line? If it's on the dotted line, it's not a solution because that dotted line is kind of like a cliff. If you hit the dotted line, you fall off the cliff. And so that point is not a solution. And neither would any point in this area be. All right, hopefully that helped clear things up a little bit. Let's look at how to actually graph this ourselves. All right, like a linear equation, a linear inequality needs to be graphed by putting it into y equals form, slope-intercept form. So right now our equation is in standard form, and we're going to put it into y equals y-intercept or slope-intercept form. So we're going to follow the same kind of steps that we used when we were doing this for equations. We want to move everything away from the y. So I'm going to start with the 2x, and I'm going to subtract 2x from both sides. Now we have 7y is less than or equal to negative 2x minus 7. Remember, we cannot combine these because they're not like terms. All right, we have 7 times y, so we need to divide everything by 7. So y is less than or equal to negative 2 over 7x minus 1, because negative 7 divided by 7 is negative 1. All right, what's the slope? The slope is the number in front of the x, the coefficient of x. So negative 2/7 is the slope. The y-intercept, negative 1. And before we move on, just to clarify, negative 2 over 7 means down 2 to the right 7. But it could also mean up 2 and to the left 7. So we'll use whichever one works the best. So we begin by plotting the y-intercept, which is negative 1. All right, we're going to go see if we can go down 2 and over 7. 1, 2, 1, 2, 3, 4, 5, 6, 7. Perfect. Okay, we also could have gone up 2, 1, 2, and the other way 7. 1, 2, 3, 4, 5, 6, 7. You see those line up correctly. Next, we need to decide, will this be a dotted line or a solid line? Well, we look at the inequality sign. It says less than or equal to. Since it says less than or equal to, we're going to make a solid line. And the last thing that we need to do is decide, where do we shade? Do we shade above or below? Well, it says less than, so we're going to shade below the line. Okay? And what that means is that any point in this shady area, and in this case on the line itself, any of those points are a solution to this inequality. Okay, let's look at number 3. Number 3, graph x is greater than negative 6. Well, this is a weird equation, right? We can't put it into slope-intercept form because there is no y. But you should be like, oh, I remember. We use this little acronym, OI VUX, to help us remember what this looks like. Now, this is an x equals type equation, so we don't even care about the OI part. We're only going to think about the VUX part. Okay, we have an x equation, The slope is undefined. It means this is going to be a vertical line through x equals -6. So we're going to go 1, 2, 3, 4, 5. Of course, it's over here. 6, and put a point. It's going to be vertical, up and down. So now we're at the point where we need to decide, is this going to be a dotted line or a solid line? So we look at the inequality. It says greater than, not greater than or equal to. So this is going to be a dotted line. Okay. And now we need to decide, are we going to shade to the left or to the right of this line? So we look again at the inequality sign. It says greater than. Because it says greater than, we're going to shade the bigger numbers, greater. So normally we say above or below, but there is no above or below. It would be more or less, right? So we're going to shade this side because these are all of the answers that are greater than -6. Everything over here all the way into infinity. All right, we will do another video about systems of inequality, so kind of putting these together. I hope that was a good explanation, and I hope you have a great day.